everybody, it's Mrs. Peachy from your WCA Physical Science class, and I'm just doing a separate tutorial today on problems with molarity and molar mass, because I was asked to do this by a few students who are still struggling with this concept, and usually where there's a few kids who are speaking up about something, there's likely more students who aren't speaking up and probably have the same issues. So I thought I would do a few practice problems for you guys and post them here, and hopefully this will help you to figure out what you were doing and maybe kind of see where you went wrong. So with all of these on here, they're actually asking for the molarity of the solution. And I want to remind you that molarity is moles per liter. But of course, first you have to understand how to figure out how many moles are in a particular compound. Remember that mole is defined as a number. It is a quantity. Just like a dozen is 12 and a gross is 144, a mole is 6.02 times 10 to the 23 power. Okay? So it's a pretty big number. So when we're looking at sodium chloride, this first example here. The first example, sodium chloride it says there's 0.5 moles of sodium chloride. So you're talking about, half of that 6.02 times 10 to the 23rd. And they have 0.05 liters of solution. So moles per liter. Now, in this particular case, they don't ask you anything about the molar mass. But I just want to kind of go through molar mass first, because this problem you wouldn't need to have molar mass to solve it, but I get the feeling that maybe the person who needs, people who need help on this may not understand yet what molar mass is. So even though a mole is 6.02 times 10 to the 23rd, and that's the quantity, depending on what it is you're having a mole of would determine how much mass it has. For example, like I said before, a dozen is 12. So a dozen golf balls has a very different mass than a dozen bowling balls. So just because they have the same number doesn't automatically mean they have the same mass. Sodium chloride is made up of one sodium ion and a chlorine ion, and they are bound together with an ionic bond. And when we look at the molar mass of sodium chloride, we look at the number here on the periodic table, which is the atomic mass. And how this is set up is that the atomic mass here, which is rounded to the nearest tenth, would be 23 atomic mass units, is actually also equal to the number of grams that 1 mole of sodium chloride would be. So if I were to have a balance, I could measure out 23 grams of sodium, and that would be a mole of sodium. Chlorine, down here, has a molar mass, then, of 35.5. Okay, 35.5. So 1 mole of chlorine would be 35.5 grams. Adding these two together, you get 58.5, and that's going to be the mass of 1 mole of sodium chloride, or table salt. So, when you're in a lab setting, or even in any setting, you can't accurately measure the mass of single atoms or anything like that. But you can accurately measure the mass of a mole of those atoms, because there's so many in a mole. And even though each atom is very, very tiny, when you get to that many of them, it can be measured pretty accurately in any kind of, high school science lab setting or whatever, using just a balance. So in this case, I were to use a balance, I'd measure out 58.5 grams of salt, and I would know that I would have a mole of sodium chloride. So that's what molar mass is, okay? It's the mass that 1 mole of that substance has. When we're making solutions, and, I'm not talking about solving problems, that kind of solution. I'm talking about an actual mixture but it's not a mixture, it's a solution. In a lab setting, we have to determine the concentration of that solution, okay? And one way to do that is through what's called molarity. I'm trying to move this stuff around a little bit, guys, just to get it out of the way. Okay, so I'm going to shrink down that periodic table, get rid of some of these calculation, or these, not that one. That's not the one I wanted to get rid of. Okay. So I got to put that one back up real quick. Just a second. Okay, I got it back here. So, when you're dealing with a solution, concentration can be measured in like percent. You can do percent by volume or percent by mass. Percent's pretty simple because it's just a ratio. It's a ratio of volume of your thing you're going to dissolve, which is called your solute, and what you're dissolving it into, which is called your solvent. So your solute to solvent ratio would be your percent by volume, or if you take the mass of the solute and the mass of the solvent, it could be percent by mass. So that's pretty simple. When you're doing molarity, it's also pretty simple, but instead of a ratio of percents, it's a ratio of the number of moles per individual liter. So you first have to determine how many moles you have. So if you're given the number of moles, like with problem 1 here, it's very simple. If you're given the number of grams, we have to do a little back calculating and figure out how many moles that actually is. Okay, so with number 1, you have 0.5 moles of sodium chloride. And you have 0.05 liters. Since molarity, which we use a capital M, is just moles per liter, this is already set up the right way. All you'd have to do is take that 0.5 and divide it by 0.05, and it gives you 10. So it's going to be a 10 molar solution of salt water, basically. The second one, 0.5 grams of sodium chloride is dissolved to make 0.05 liters of solution. Now, if you remember up here, we figured out the mass of a single mole of sodium chloride. 1 mole of sodium chloride is equal to 58.5 grams. So we're given 0.5 grams. So we need to determine how many moles that actually is. If you only have 0.5 grams out of 58.5, it's obviously not nearly a mole. So let's take that 0.5 and divide it by 58.5 to figure out how many moles we actually have. Okay? So, I mean, it's really small. It says, basically, it's 0.009 is the number of moles. Okay, and we have that in a pretty small amount, 0.05 liters. Okay, so if we divide those two, I get a molarity for the solution of 0.17. Okay, so that's my molarity of that second solution. Now this one, got to be kind of careful, because in this last one here, it's asking you about the same thing, but it gives you milliliters instead of liters. And remember that a milliliter is actually 1/1000th of a liter. So to convert this to liters, we need to divide by 1,000. 0.05 divided by 1,000, is the same as moving the decimal point 3 places to the right. So 1, 2, 3. So it's, oh, I lied. Sorry. 3 places to the left, I was thinking, because, okay, my bad. So it's 1, which gives us 0.05, 2, which gives us 0.005, and 3, which gives us 0.00005. That's how many liters it is. I mean, it has to make common sense, and that's how I realized I had screwed up there, because this is going to be a lot less than a liter. And if I would have moved it the other direction, I would have said, wow, 0.05 milliliters is equal to, I don't know, like 50 liters. Whoa, that's crazy, because it's not real. I obviously screwed up on that one. So you're going to take the same thing. You're going to take this, this amount of moles that we did earlier, because we know 0.05 grams is 0.009 moles. So we did that part in the first problem. And you're going to divide by the liters, which is 0.00005 liters. Oh, I think I messed up. Okay, 0.009 divided by 0.00005, which is crazy. It's 180 molar. What? That's pretty intense. But salt water, so it's just really salty. It's not like it's going to do anything but, really dehydrate you badly. Don't drink it. All right, so hopefully those few sample problems kind of gave you an idea of what you might have been doing incorrectly on those. If you still have questions or concerns, you'll have to contact me after break if you can't reach me before 3:15 today. So hopefully you guys understand that and have a happy holidays. Talk to you later.